Okay. Hello everyone. Welcome back to the stream. So last week we did a lot of work on the code generation phase of the compiler, which was the last big thing that was missing, and we ended up being able to start generating some basic programs. We ended up with, where is it? It was called test. If I open it there, it's gonna be way too small. I'm gonna open it in GIMP again. We ended up with our first program. It's very limited. I don't think this is the most up-to-date version, although this one does have the termination thing here. Why is this not the most up-to-date version? Let's see. So now I should have a test PNG here. That's not the correct one. Oh, program PNG. I opened the wrong one, that's why. So this is our first program generated at the end of last week. It computes a Fibonacci number. And this is our main, well, our start. Here's our main, here's our recursive Fibonacci function. So we are at the point where all of the parts of the compiler are starting to work. However, we are extremely far from having a compiler that really works. We're missing a lot of features. Something I want to do this evening, and I want to start this week, is to start putting things together in a slightly more organized way, finish the full pipeline so that we can start cleanup, test, and then add new features in a more incremental fashion. So let's get started. What I want to do specifically is here at the root, I have a PC program, which is the Piètre compiler, that for now just takes a file and prints a bunch of things in the console. The definitions we found, the functions we found, the symbols we have exported, the IR, and so on. The work I want to do is to start to make that a proper compiler, something that extracts the graph of dependencies, builds each of them, caches some of them if possible, but also written in a way that allows for some tests. And cleans a tiny bit all of this mess and hides that behind like program options. So yeah, I will want, I think, to put that not in the main thing because I would like to be able to test that code probably. So that's probably gonna go. I don't think I have a folder that matches this, so let's call that the pipeline, I suppose. What will we want? We will want a cache, a build cache, I think is the most important part. Let's think about this for a second, because yes, we want to build cache, but we also probably want to hide all file system operations behind some kind of interface so that we can write tests in a way that don't necessarily depend on actually talking to the file system. What API do we want for this? I think we don't want to like redefine. We already have in the stages, we already have basically an interface for each phase. Like we have parse module that, given a file path and some text, will give me either a parser or a module. Oh, in fact, this should probably be rewritten to make use of my diagnostic method, I suppose. Because parser, I think for now is still some string. That's one thing we're gonna have to fix at some point. So what do we want here? Because at the same time, we don't want a function that takes a source and does the whole thing, because we will want to be able to control what gets done. So I think the build graph is going to be our first step, I think. Because what we're going to want to do is basically we get a file as input, we pass it to get its imports, meaning we can then now go look at the files that have been imported from this and then pass them, look at their imports, or perhaps look at the cached dependencies from them and create a build graph. I think that's what we need to do. This will be what will give us the list of operations that need to be performed. One thing I want to change, come to think of it, will be in the representation. I have this interface thing, which is the result of doing some basic validation, doing like all of the analysis on a given file. We get what is exported out of this thing. We get the cache of the definitions of the functions and the symbols that must make it to the compilation unit. I think I want to add a thing there, which is the interface dependencies. And that will be something that we can find in the AST. If we look at past here, an import, that is this. And that is not something that will be resolved in the analysis part of the compiler. So I can probably just reuse that as part of this. So this will be just a sequence of import. That way, because the goal is, of course, to cache this as part of the interface, I am planning to do the same thing that Haskell does, basically, which is for every module to have two cached files. One which is the interface, which contains everything that is needed to compile something else, and the actual object file that contains the bytecode that can then be assembled. And this is basically what will be cached for a given module. This is the output of the first phase. So now, with that done, I should probably start with actually fixing the places that create that structure to make sure that they're all created correctly. Fix this error here. Hide this for now. Clean this so that it compiles. I'm trying something new with the sound. I've made some tests. Apparently having the microphone closer to me makes for better sound. I just need to talk a tiny bit less loud. So I'm going to try that. This would be past, although I think the prefix past isn't going to be required because import is not ambiguous. So now there's one place where we're going to be creating this interface, and I just want to fix it first. I don't remember what that is, but compiling will tell me. There we go. Here I'm creating the interface, and I'm not actually adding... this is the analysis of a module, okay. And this contains the module there, and the module info contains the information about the export, and that is, if we go back to past, that is the mod imports of a module. Okay, so here this is just relaying the mod imports of the module, and this is the field interface dependencies. Okay. So that should be fixed now. It is not, so what is wrong? Ah, this is a list, while this is a sequence. At some point I will probably want to make that a list as well, but for now it is enough to just... create the list, the sequence from the list. Okay. Except, of course, this is the wrong syntax. Oops. This should be better. Ah, yes, of course. In a module, if we go back to past, here they are with their location, which I don't need to persist past this. So if I look at the location, I can probably just get the located thing. There's a lens for this, but I can probably just use the field, which here in this case will be just doing a map located on this thing. There we go. Now, we can go back to our idea of a build graph. So what will our build graph look like? And how can it give us a build plan, basically? This will be a tree of dependencies. We'll find out that file A depends on file B, which depends on file C, and so on. The question is, do we want to store information like the interface in that graph to be able to adjust, or do we just care about the dependencies of a module? I think for now we only care about the dependencies of a module, which means a node in our graph is going to be simply a path for a module, I believe, will be enough, or something like this. Well, path is the wrong type here. So what file this is, do we want to store? We probably want to store whatever most up-to-date information we have so that we can decide what needs to be done based on this. I'm actually just wondering, do we actually need to build a graph with a node that has like subnodes, or can we instead just build a build plan directly without going through the intermediary step of building the graph? The upside of doing directly the build plan is we don't build the graph in the first place, which saves us this representation. The upside of building the graph first is we have more flexibility in what operations we want to do. For instance, if an option was given to stop at code generation and not do the linking and assembly, then we can use the graph but generate a different plan. So I'm tempted to, for now, keep this idea of a graph, or a tree rather, and no, I guess it is more of a graph. Because there can be diamond stuff. And then generate a build plan from that. So this will be a node in our graph will be a file, which will be a unique file path. It will probably contain, well, the info, which will be node info, which will be something else. And it will contain a list of dependencies, or a sequence of dependencies probably, which is just going to be a sequence of other nodes. Okay, and what is a node info? And this is going to be either a source, and it will contain a module that is just the past thing and nothing else, or this will be an interface, and it will contain, I don't think the module is even needed. I think the interface is more than enough, or it is already an object. We already have compiled this in the past. We still have its interface, and we have an object file, which we haven't defined actually. That's something we need to define. What would that be? I guess object is a word for this. Now, the thing is, we probably want to define what an object is. We haven't defined that yet. That would be probably in the output of the generation, I think is what we want. At the end of the generation, what do we have? We have, for one function, we have an instruction buffer. I guess for a module, the only thing we care about is the symbols, which is the instruction buffer for each symbol in the thing. I suspect as a result, if I go back to my representations, where do I have, where have I defined this instruction buffer? Probably in the bytecode here. Yep. I suppose then an object file, the result of doing code generation and doing everything up to linking and assembly, will be a hash map from name to instruction buffer. So that will be what we will have in our build graph if something was already compiled and was in the cache. Okay? From that, from having just this graph of things, we'll be able to build a build plan by traversing the tree to be able to guarantee that the root at the end, the main, has an object, and we'll collect the list of objects from that. Okay. Now, how do we build this? I guess it's a the build graph, construct build graph. So this will take, I guess, a file path, which will be the module that we're currently passing. This will need a bunch of other things as well. This will need some context, which will be given through some kind of monad that we'll have to decide, such as what paths are considered for imports, that kind of stuff. And we will need to be in a monad that hides access to the file system so that this code is not necessarily in IO and can be made into something else. Oops, sorry about that. Can be made into something else for the purpose of tests. So let me actually just look at something. The main that we have here. What do we do? Yeah, file names are just strings. So for now, I think that's good enough. So this would be the main. And the result of this will be in some monad m, the details of which will have to be specified, will be a build graph. And I guess the build graph is just the root node. So what will we need? First, we will need to call the parsing. So we'll need to parse module on this file path and the text. So we will need to know the content of the file. That is something that this thing should hide. So we will need, I'm going to put it here for now, but I will probably put it somewhere else at some point, a class which is the like the interface for file system access. how do I want to name this? That's like monad. Is it a monad build system? No, that's way too abstract. Monad file system is a bit incorrect as well. Monad build is not the worst. Okay, so what I'm saying is basically an interface in which I am saying that this M thing is able to do such things, such as read source file, which given a name of a file path will give me some text, which is a source file, in that particular M. That way, in actual code, I can use IO, and this can be a read on a file on disk. In tests, this can be something that returns a hard-coded string. Okay? So I know, actually, I'm gonna do this here. This is gonna be a monad always. Here I can just say monad build. I don't have like this is this whole thing of let's build a build graph and a build plan and everything is a much larger task than something like let's do the code generation. So there's going to be a tiny bit more improvising is not the right word, but throwing stuff and see where it leads us this evening compared to the slightly more tight neat thing of last week. So here the first thing we're going to do will of course be to I guess, do I need, is it just build node main file? And I have build node takes a source path and does get the source text by doing read source file, which we know we have the capacity to do of the source path, which gives us either text or error. What is a parse error at this point? Where is that defined? Probably in there. Parse error is a string for now. That's not great. We'll probably want to merge that with our internal diagnosis thing. But for now, for the purpose of making progress this evening, let's accept that this phase will be... Do I want, actually... Do I want to say... Because I think I have a... I have a monad diagnosis class. Yeah, I think this is as good a time as any to start fixing some of our issues. So this monad M will need to be a monad diagnosis so that we can report errors there in case they fail. And if I compare, for instance, the parsing phase of our compiler there, that just gives me a parser, which is a string. If I compare that with the analysis, this is something that operates in monad diagnosis and will give us an interface or throw an error properly in case something happens. So I think we probably want to rewrite this as given some monad diagnosis M. This is a list of location token. We might want to make that a sequence at some point. I'm trying to remove raw lists in the code. The same logic applies here, given some monad diagnosis. That's that. There we go. So run parser here is something I'm gonna have to change based on that information. It's gonna be here, but before that we probably want to change our diagnosis to contain error lexing with just a string for now, just for this evening. Error parsing. And now that means here I probably want, if I want to distinguish between a lexing error and a parse error, that means I probably need this to not just be a string, but to contain... Could this be actually just a diagnosis here? And if that's the case, do I have something here to do a from either, basically? I don't. That's not extremely complicated to make. And I probably want to do that. This would be a hoist either. Given some monad diagnosis M, and either a message, I guess? Or maybe either a diagnostic, probably? Or some value A gives me an MA in that monad. And hoist either is going to be, if I look at my class, report error would be that, so that's perfect. That's basically just a flip on left. And oh, it depends on how I've defined on left, I suppose. Takes the either first, so yes. This is a flip on left of report error. That's assuming that it's not a warning. Maybe I shouldn't do that then. Because if this is a warning, it's gonna be reported as an error. I think that's fine, because by definition I don't have a value otherwise. So I think this is fine. Okay. That means here, if I go back here, I get my initial state, I apply f, which is the parser here. That's a parser state to either diagnosis, so I get diagnosis and this. I fmap first to get either diagnosis or A, and I can then hoist either, the function we just created, at the end. And this will be, given some monad diagnosis M, an MA here now, which means that back in here, nothing needs to change. Okay. Now that means that the places in which I report errors in the parsing stuff will have to be changed. Because now this is either diagnosis, and except diagnosis, parse error can just go away. Not diagnosis, diagnostic. Let's try to compile that, see where this breaks, and fix that. Yeah, of course. Do I want to... So it seems to be... Oh, of course, I'm just missing here the import that I have. Beg your pardon. Okay. Now, here is where I throw an error. And that is no longer something that will work. This will now need to be a proper diagnostic. So let's have a look at what the diagnostic is again. It's a declaration, a location, and a message. The declaration is gonna be nothing. I am not in a particular declaration because this is an error while lexing a file. Location will be here. I do have a line and column, and I believe my location is okay, file name, address, line, column. Oh wait, I'm an idiot. This is the full location. So that's what I want to report, the current location. And the diagnostic message. Well, that would be our new message we've added. Error lexing. And when we encounter a lexical error, for now, we have no information whatsoever. Which is a tiny bit annoying. But for now, that's all we have, okay? Next, where else are we creating... Actually, and this might not even need a $sign here. Oh, did I remove? Ah, I didn't save. That's why. Okay, and here's the other one where we will be creating a parser error this time. So location. And this will be very similar. This will be throwing a diagnostic where the diagnostic declaration is nothing. We are not in a specific declaration because we are failing to pass something. Our diagnostic location is going to be the current location. And the diagnostic message will be a pass, error pass, I suppose. Passing. And here we do have some information. Found this expecting this. Although I suppose rather than constructing the string here, I could do a thing where this is error passing tokens, token and expected. And here I have token List of string. Hello, how are you? Token here is not in scope. That should not be an issue, I think, in terms of circular things. I think it's tokens plural. Pass error. That's ironic, since this is the code that reports a pass error in our language. Okay. So message is incorrect. Oh, token is not in scope. Oh, I did break something here. So let's have a quick look at what is happening there. Where did I break there in this function? Okay, this takes a tuple of location token, and I've changed that by mistake. There we go. Okay, let's see. Okay, we're not there yet. So this is the last thing missing, I think. This is just missing the import of internal diagnosis. There we go. And while once this is done, we're not there yet. Yes, here this is a in the monad and not. Oh, did I change run parser correctly on that note? Because run parser needs to also. Yes, I did change it. Okay. The last statement in the do block must be, and yes, of course, this was where I stopped. Just gonna say unimplemented for now, which I'm gonna need access to internal compiler errors. There we go. Object is not a thing that exists. Oh, it is, but not. Okay, perfect. Location, oops. Location not required. Name is redundant. Redundant constraint, perfect. Just gonna comment that out. We're gonna need it afterwards, but I just want to see the rest of the code compile. Okay, so yeah, this is now the only thing that's no longer passing. I'm gonna keep this. I'm just making sure stages passing is in scope. Okay. So now what that means is that read source, here I can do a pass module, and pass module, as we have seen, takes file path and text, which we now have. Source path, source code, I suppose. And that puts something in the monad diagnosis. Therefore, here I get the result of pass module, which is the module, which is a keyword in Haskell, so I can do that. There we go, which means I need this again. And now I have part of the node. The only question is, I will need to do, and that's going to be part of my monad build, lookup cached interface for a given file path. Give me maybe an interface. Cached object. Maybe object. The idea of this is, again, I'm not saying this has to be in IO, which means I am free to use IO in the actual main code, but tests can substitute here something else that doesn't touch the file system, but the rest of the code behaves the same. I'm just saying that this one in which I am has the capacity to do those things, but how that capacity is implemented depends on what M is, and that can change based on where my code is called. So here, after I do that, I can have a look at the node info will be a lookup of the cached interface of the source path. In case it's nothing, then the only thing we have is the source, and here's the module that goes with it. Otherwise, if we do have an interface file, so the file is probably already compiled. Oh, does it ever make sense to get the interface of a file but not its object? Because those are two different things. I guess it makes sense if I have interrupted the compilation of the module before the object file was generated. So here I have to separate the possibility that, like most cases, I will either have not compiled yet or compiled, but the possibility of we have the interface but not the object is technically possible. So I need to handle that. So here this will be a case of I look up the cached object from the source path. If it's nothing, then I can return that I have the interface I, and if I have the object, I can return the object IO. Okay, so that will be the node info for the thing we have just passed. But more importantly, regardless of whether we have cached stuff or not, because that cache might be, oh, I need to be careful, that cache might be invalid. That cache might be invalid, which means I guess technically this is that. I don't know if I like this thing, this sum type there. Because it's basically, do I have... It's not the worst, I can keep it like that. Okay. So here this always returns the node module as well. It's always included no matter what phase, so that if the thing gets invalidated, I can regenerate it. Okay. But now I need to have a look at the... I need to have a look at the dependencies that are coming from the module, which is in past. So I need to look at the mod imports of the node module. However, where I want to be careful is I want to build a graph. I don't want to, I want to only include one node per. I only want to include one node per thing. So how do I deduplicate? If I include A that includes B that depends on C, and I include A that includes D that depends on C, I don't want to compile C twice. I guess I could still represent that as a tree where B depends on C, D depends on C. Or I could, instead of trying to make that a tree graph-like structure, I could instead have my graph be just the dependency information and have the key. Yeah, maybe I'm going to do that. Okay. So a node does not contain the node info, just contains the name of the file and its dependencies. And the graph, the build graph, is going to be the tree node, tree, root, which is the node, and for each file path, it's going to be a hash map from file path to node info. That way, if two nodes are pointing to the same, then it will point to the same node info here. This is how we will break cycles in a more efficient way. Okay. Now, how do I detect cycles? That's also an issue that I haven't considered. I guess because it's fine to encounter a module in my dependency that I've encountered before, unless this forms a cycle. I think the thing I need to keep. Yeah, I think it's the easiest. Yeah, exactly that. I just keep track of the ones I've already visited. But I keep the parents of the current one, not all the ones I've already visited. That way I can just check, do I have a circular dependency there? I think that's the easiest way. So that means here I'm probably gonna run this into some kind of state. So this is gonna be an exec state T of this action using an empty hash map as my state. I just need to quickly check between exec state and eval state, because as usual, I never remember which one is which. I said exec, is that the one I want? I want the one that gives me the S parameter, which is the state. Ah, come on. Exec state was correct. Okay. Okay. That means here I have this hash map. In fact, that's not true. I want a run state T. That's gonna give me a pair of the value and the state, which will happen to be this and this. So this is just gonna be create a build graph using this tuple as if it were its argument. So this is uncurry of the build graph of flip run state T empty of build node main file. Okay. And so now this thing needs to return the node, but needs to modify the state at the same time. And I need to keep track of the parents. I'm probably just going to use a hash set for this. So I need to import data hash map strict qualified as M to have it in scope, and hash set as S to have it in scope as well. So now this is parent and source path. Now here, what I can do is I can start with if source path member of the parents, then report error. We are in the monad diagnosis, so I have access to just something called report error, I believe. Report error that will just short circuit, so I can even do that as a when. I don't even need to do it as a if then. And the error will have to be a new one. I don't have one at the moment. There is an issue, however. Oh, no, this takes a diagnostic. Okay, very good. So this takes a diagnostic, which means I need to supply not just the error here, but also the location if I have it. I don't. No, I do. I do have it. That's perfect, I think. Okay. So I will need to add a new kind of error circular import, which will contain the source, I suppose, or the module name. Do I have access to the module name? I should have access to the module name. And probably the list of module names that form the chain. But if I want the list, then I can't use a set here. I have to use something that maintains the order. But I want something that gives me also... Oh, do I have a dependency on... I think I have a dependency. Ins ord. I don't. This one. Because this thing folds in insertion order, so it will remember the order in which things were added, while at the same time being a set, meaning that a member check... It doesn't give me the complexity here, but it should be something that... that still has a much faster thing than doing a iteration on the list. That being said, this is going to be a very short list. Maybe for now it's enough to just have this be a list. Well, not this. This. And this is going to be the main file. And so here I think this is going to be file path and file path. So now here, if I find a source path that's part of the list of parents, then I can report a diagnostic where the diagnostic declaration is nothing. I'm not in a specific declaration. The diagnostic location I would need to know the location. I can... I guess here I could use the file that does the import that creates a... For instance, I have a file foo that does the import that is wrong. I could use the location of that import, which means I would need that to be given here. Which would be a location, I suppose. However, this will be nothing at the root. So at the root, I don't have an import statement. So I guess for the root, either I do nothing and I substitute something, or I directly give the substitution. And I suppose, well, it's impossible for it to happen at the root, right? The root cannot... Yeah, this cannot happen. So whatever I give here will always be unevaluated and unused. I could consider giving a internal compiler error here. Like this makes no sense for this to give me something that is like without an import statement, there cannot be circular imports. So here, yeah, this can never be evaluated. Except when I do this kind of bug. Impossible location. An impossible location will be an internal compiler error because it makes no sense. Okay. So here, this will always be, in case of error, the input location, and the diagnostic message will be whatever we've decided is the thing, which we said was an error circular import, where I have this source path, and here's the full list that led me there, and that is the parents. And that will probably be a reverse of the parents, because I'm probably going to be appending at the beginning, and this is a classic LM, which means I need data list qualified as L. Okay. Okay, then we do all of that. Then I get the imports, which means I get import with location, or I guess I could decompose them here. So that's a with location of the import location, which will, so the dependency import location, and the dependency whatever is in an import. And for each of those, so this is going to be my dependencies. ultimately. For each of those, I will build node recursively and return that. So I will build node. The parents will be the current source path at the beginning of the parents. That's the new location, import location, and the source path will have to be figured out from this, which is going to be find file from this import statement. Okay. However, there's one thing I have forgotten here, which is I need here to look at my cache. So here I need to do a get of the cache on which I do a lookup of the source path. And in the case where I have just a node info, then there's no need for me. That's a problem, because I want to. I want to cache the node there, I think. I want to cache the node so that I. That's annoying. Because I want to avoid. Let me think about this for a second. Do I still need this tree-like structure? Or is my hash map in fact enough? I need to persist this information there, because I think this is just a sequence of file path at this point, which could fit into the node info there. Do I need to keep this graph or not? I can keep it, I think. But that means that here my state will not be that. I will keep the node as well as this. So that means this uncurry will no longer work. So I will have to do. I will get the state and the nodes. So the idea of the graph is I want to create the build plan, basically. As in, okay, you've given me the main file, and I've extracted all of the dependencies. I have looked at my cache of partial builds because we're going to support incremental builds. I want then to just create the build plan. We need to compile this file. Here we have a cached version, and do that. However, I don't want to write the build plan in a way that like one big function that skips creating the graph in the first place, because not all, depending on the options given to the compiler, we will not always do the same build plan. For instance, I will want sometimes to just, okay, only build up to the analysis, only create the interface files, do not actually build the bytecode, that kind of stuff, for debugging purposes and other reasons. So having something that gives me the actual graph of here's the graph of the build, and then from that something that gives me the build plan based on what plan I want to make, is a separation I think is useful. But again, this part of like build plan, build graph are things I hadn't planned ahead. I want to work on them now because I want to figure out how a build plan works so that I can figure out how I integrate built-in functions. Because I don't have built-in functions yet, and I really want to have built-in functions because I want to be able to add actual calls to print in this rather than having to inspect the memory of the interpreter. So that's the chain of things. But I didn't really plan this stream ahead of time for once, so I'm a bit more improvising this idea of a build graph and the nodes and everything. Maybe this is something I think it's not completely wrong to go it this way, but this is something that like by doing it, I am hoping to identify things that work and things that don't, so that we can refine it. Okay, so here that means I will get my value, which is going to be my root node, and I'm going to get the full state, which is going to be the node map from doing a that. And here I will be able to create a build graph by giving it the root node, but here I will do an fmap second of the node map. Okay. So now here I can do this get on my state. In a case where I have the node info that I don't care about, and rather in case I have the node and the node info, and I don't care about the node info, I can return pure of the node. Otherwise, if I don't have anything in the cache, then I feel like I write something in the cache like this so many times that I should probably at some point just make a monad for this and reuse it. But I don't know if there's a way to make it generic based on like it might be complicated. No, it might not be worth it, is my point. Okay, so here I do get the node info, so my result will be the node is going to be a node that contains... Oh, here is how I process my dependencies. There we go. Then the node will be a node that contains the file path, which is the source path, and the dependencies, which are the nodes I have obtained by calling build node recursively. I can modify my cache to do an insert of, for this source path, this node and the node info, and return the node. Okay. So now the only thing that's missing is I'm going to name it just for readability. Find file. And find file is going to be something that, given some build monad or whatever I've called it, monad build, and a file path, or rather no, an import, which as we know is this non-empty identifier and import type, and I only care about the path, will give me a monadic file path. And this will probably need to be a monad diagnosis as well, because I will need to be able to handle in fact, this file doesn't exist. So this implies that this monad build has the capacity to look for a specific file in the file system. So it will probably be something that carries information such as what are the import directories in which we look for dependencies. So that means I'm gonna go back and add, there it is, find source file, which is given a relative file path, gives me a monadic file path, which would be find, is it not absolute path? It is absolute path, so find absolute source file, find source file. I'll have to make it clear this is the relative path, this is the actual concrete path, okay? So find file here will be a simple thing that given an import that has a list of identifiers, which are going to be the path components, will be a simple call of find file. How did we call it? We called it find source file. There we go. Find source file of, we translate those path components back into a we translate those path components back into a relative path. And for this, how is it called? How's that called? That module again. Is it system file path or system directory that I want? Oh, come on, is hackage down again? Oh, that's annoying. I really need to build a local copy of my documentation. I haven't done that. Yep, hackage is down again. Great. Because if I look for, is there something that takes a list of file path and concatenates them into a file path? Join path in system file path. Okay. Because that's what I want. I want a join path, and I will want to translate those identifiers back into, and that is that's not gonna be a show, so it's gonna be a text unpack of a raw identifier. Oops. Of the import path. Well, of the path components. So I will need to import system file path from here. Okay. Am I missing anything? I think that's about it for now. Yeah, Hackage has been having a lot of issues recently, and I don't know exactly what it is. My speculation and the speculation of others in the community is that it's probably AI companies like spamming for requests and just harassing the thing. Yeah, it's back. It's in showing path. Yeah, that's what I wanted. Okay. So that's the find file here. So this should only do the lookups and everything once for each file that has been found, and delegates the responsibility of translating a file path into something to the call monad, which for our main will be something that is aware of the options to know where to look for a given file and looks on the file system, while in test this will be probably a hard-coded list of files, and that's about it. Okay. So that should be something that gives us a build graph. And that needs to give us a graph and not a node. Let's try to compile this. Let's see what we're missing. Aha. Yes, this is... Okay. Something else we're going to need to do is figure out a file format for persisting an interface and a series of objects. But that should not be complicated. I am thinking of using the binary library for this because it is one that is used by GHC for a similar purpose. So again, trying to keep the logic of trying to keep the logic of using the same tools that GHC uses. Did I not import? Oh. That's given me. That's because I... There we go. Okay, so now we get the fun errors. So we are giving a state t hash map file path node info something node. Okay. Expecting something different. Interesting. It agrees on the type of what's needed. It agrees on the type of this. However, the type of this is where it's wrong. Okay, so what happens if I type this explicitly? This takes as arguments a list of source path. Import location is a location. The source path is a file path. And this returns a state t. I'm gonna need a for all m for this. A state t of a hash map from file path to node and node info. Oh, did I make a mistake? No. Okay. On top of m, and this returns a node. Aha. So here something is wrong. Oh, of course. I might... I think it's fine to decompose it like this. It just makes for a long line. Okay. So here, dependencies, this was a list, therefore this is a list, but this needs to be a sequence. So we are back to sequence from a list there again, which means I will need to have data sequence quantified sequence. There we go. This comes from representation identifier. Okay. Actual, oh, this is a non-empty list. Okay, that's fun. But I can to-list it without any problem, because it's always possible to convert a non-empty list into a list. Now, read source file. Aha, that's interesting. Indeed, I have said that monad build is like I have said that whatever monad we are operating here is a monad build, but here I am operating in state T, and there is no guarantee that state T on top of my other thing will be properly a monad build. I could provide an instance, which I will do ultimately, but here I could also just lift a read source file. And probably a lift and probably here a lift. Okay, and here likewise, lift, find file, redundant constraint, monad diagnosis. That's because I did not. No, I think I will. Okay, no, here I'm gonna make this a maybe file path. Do I want to make every single function in this return a maybe and have to handle errors? Or do I want to make those functions aware of the logic of monad diagnostic and of monad diagnosis and have those functions written in error whenever that's required? I think this one, since the resolution happens first, will have the guarantee that this exists and can do an internal compiler error otherwise. Sorry, this one. However, this one, yeah, probably returns a maybe. And here, if it finds nothing, then on nothing m, report error. Actually, I'm just gonna make find file. Just gonna check. Yep. A part of this, because it's just a call to that. So it doesn't need to be its own dedicated function. And instead to have access to the information I need for the error, when I do a find file, which is here, on nothing m, if this fails, then report error, and that's a diagnostic. And the diagnostic declaration is nothing. The diagnostic location is the import location. And the diagnostic message will be error file not found, I suppose, with the I'm gonna go even one step further. Dep file path. Up, and this is make file path, and that's that. Okay. And here, in case where we didn't find it, and we report error file not found of the dep source path. File not found doesn't exist yet. We need to add it to our list of diagnoses. Error file not found with a file path. Let's be consistent. In fact, to be consistent, I should have all of this be source path. Okay. Oh. So this would be the relative. This is the actual source path, the absolute. So this would be the relative here as well. And in build node, we do call it the source path. Okay. And here, okay, so main is broken now, but main being broken, that's fine with me for now. Because by definition, although I guess since I'm currently adding new code, I could fix this. So I am in a run diagnosis T, which means here, this on left error show is no longer required. Now parse module should be delegating into the diagnosis monad correctly. Yeah, okay. Okay. So now we have this function that, given a file path, does attempt to parse the files recursively, does call to the interface being provided to do a lookup of the cached interface and the cached object, if any, if there is a build cache. And otherwise, it gives us a build graph, which is starting with the node, which is our starting path, the actual absolute path of the file on disk and its dependencies, nodes being deduplicated, and also a hash map for a given file path, the info that we have on it, which is either just the source or an interface, so the source and the resulting interface, or all of it, the object, and all three of those. Now, this is incomplete in the sense that we probably want to also add some timestamp information on all three of those, because we will need to know if it was. Oh, unless those functions actually return nothing if the thing has been invalidated. But that's probably not something that they can do there. They will need to know, has any of the dependencies been updated? If yes, do that. Okay, I think I'll need to spend a tiny bit more time thinking about this, because I can tell that I am not being very efficient at it this evening. Because I don't have a very clear picture of how I want to do this for once. So I think with this done, I'm gonna put it aside for now and resume tomorrow or Thursday whenever I do the next stream. There's something else I wanted to work on that I can do this evening while I have some amount of brain capacity. And that would be a quick cleanup of something we have done. I want to go back to stages generation. There's a thing I want to do here, which is that when I generate the bytecode for a function, I get this instruction buffer, which is a series of a sequence of basic instructions. I could do a round of very simple optimization on those, and that would reduce the size of the generated images quite significantly. And I think I'm going to do that. So simplify will be something that takes an instruction buffer and returns a new instruction buffer. This is going to be the only export of this file for now. Just going to copy this for now as well. And the idea is that here at the end, I will always run simplify on this. And simplify will be given a list of rules that will be somewhere in this thing, and what is rules is going to be a list of rule, and a rule is a tuple of. No, actually, I'm going to write it differently. Okay, so simplify is going to be something. I'm going to need the rules function, which is going to be a series of, given a sequence, given an instruction buffer, give me a new instruction buffer. Because I want to be able to know, did a rule apply? If yes, we need to restart from scratch. Okay. Yeah, I'm gonna do it this way. I think. Ah, wait. Ah, this is a bit more complicated than I thought. Because I want this as a function, because I want to be able to match a particular pattern within. Okay, not my best stream this evening, not my most productive. That is absolutely an example. Yeah, I want to remove roles. The only thing is sometimes several rules will have an effect on instructions before. And so, for instance, I have two roles that end up being like removing one another, and that ends up removing an instruction before or something. So I'm trying to figure out a way to express each rule as a pattern matching on a part of a sequence. I probably want tails actually. Okay, so maybe a rule is something that given a view L, which is where is it again? A view L of instruction unresolved gives me a corresponding view L. Well, wait. The problem is a view is gives me maybe a sequence. There we go. Okay. Now I will have rules, which is going to be a list of rule. And then simplify will be, I have my instructions, and I will do a go on a view L of the instructions. So maybe I can just do, no, I will need to have it in scope. So when I end up on empty L, that means I have traversed, it means I have traversed all of the sequence of instructions without ending up with a pattern that match any of the rules. That means I can return. Well, do I need to reconstruct things, or do I take as an argument the new sequence? I think I take the result as an argument, so that is that. So maybe this becomes. And here, if I have do I really want to use this view L thing, or do I just want to Maybe I don't need to do that. Maybe I could... No, I think I need to do it this way. I need to do it this way. Do I want to iterate on the sequence first or on the rules first? So basically, for a given rule, do I try to iterate on the entire... Maybe, okay. Then I rewrite this as being... This takes an instruction buffer. Yeah, so this takes an instruction buffer, returns maybe an instruction buffer. That's a rule. And as a result, I will just go with my rules on my instructions. And if I have no rule to apply, then that's the result. If I have a rule R and a rest of the rules, then it depends on case apply the rule on the value of the thing. If the rule did apply, then I have to restart from scratch. I go on the... If this gave me new instructions, I have no choice but to reapply all of the rules on the entire new thing in case this caused new rules to match. So I have to restart on this buffer at the beginning on all the rules. Otherwise, this rule did not apply. Move on to the next rules. Okay, that will probably work. Okay, so this will be a list of hard-coded rules. What rule do we have? Merge roles is definitely one. No, I think all the rules, well, unless I am able to like make a graph of rules that depend on one another, but I think it's easier in terms of implementation to say, well, one of the rules matched, therefore the instructions have been simplified, therefore I rerun all the rules in case new rules match. Because you could have a thing where you've eliminated an instruction that was not needed, which brought two instructions together, and now those two can be simplified, so a rule that was previously applied and didn't apply before now applies. So I think this is, you have no choice but to go through all the rules until none of them apply anymore. It's a thing, is like if a rule applies and I get a new buffer, I go recursively on rules, the list of all the rules, so I restart from the start and on all the rules, not a subset. I only continue on the subset if the rule did not apply. So I try rule 1, if it didn't apply, I try rule 2, it didn't apply, I try rule 3. It applied, I have a new buffer of instructions, I restart from rules, a set of all rules, until I end up in a case where there are no more rules to apply. Because here, oops, here I restart on the full list of rules. So we're going to have merge roles, which is going to be a rule. And merge roles is going to be something that iterates through the list of... So this is going to be something, I'm probably going to use a function for this. Because this is going to be a fold kind of thing. The fact that I'm using a sequence on the list makes this a tiny bit more complicated, but I really don't want to use lists for that kind of stuff in the first place. This is gonna be a view L of the thing, on which I do a go. So if I encounter or could I do it without a view actually? Can I do it on a sequence? Yeah, I can probably just do it on the sequence. So if I have, is there a pattern for an empty list, or am I condemned to, no, there is an empty. Okay, perfect. Well, can you imagine, is there a pattern for it is the thing? Is there a pattern empty? Perfect. So if I find an empty list, then I return nothing. We did not apply anything. If I find, however, a sequence of instructions, then what do I do here? I want to only apply so if I end up, if I do a take there, so if I do that, so merge roles, no, I think it should do that because in this case, in the example that you give, I will apply the first rule. The first rule will not apply, so I go recursively on the second here, but go buffer rules RS, so the remaining. But on this second one, the second one applies, so I get a new buffer instruction. I go recursively with the new instructions on rules, the set of all the rules. Oh, did my microphone cut out? If the second rule applies here, this R, which is the second one applies, I go recursively on all the rules again. So I will restart on R being nullify role, the first rule, and therefore it will apply again. Because here my recursion goes on rules, the set of all the rules, not on RS, the subset. So the second one of the rules apply, I restart on all the rules. Let me know if my microphone cuts out again. As far as I can tell in OBS, it seems to... Ah, that happens. I'm just trying to figure out how I write this. Because if I do a take on... do I want to do a partition, basically, here? Like a split, actually, rather. So this would be something like, do I get a pattern here, which is the result of doing a sequence split at, here I will need to split at 6 of the instructions. such that here I have push int n push. So that's depth1 push int steps1 roll push int depth2 push int steps to roll. Okay, so when we have this pattern, I'm gonna need here overloaded list for this. Although I don't know if overloaded list actually works for patterns. Let's see. For construction of structures, yes. List patterns are also overloaded. Okay. Perfect. So yes, I can use that as pattern matching. And I'm not sure actually here I want to apply more than one thing. I think it's comma. So here I want to do the case where I find this particular pattern and depth1 equals depth2. If I ever find this pattern, then I can return a new series of instructions, which is going to be, do I want to keep track? Do I want to keep track for debugging purposes of which simplifications have been applied? Like for verbose, probably not. I'll have to think about this. So here, what we're going to apply in this case is, yes, we do have something to replace. This is going to be a push int depth1. Yeah, I think I will want to have some kind of log for this. But maybe this will be, rather than being written as part of this, I will at some point have some kind of like monad log or something that is able to process logs according to verbosity. And then this function will be monadic based on the existence of this monad log. So I think I'm not going to bother returning things out of simplify. Instead, at some later point, I'll do something that is monadic and knows how to deal with logs. Which, because I think a lot of parts of the compiler will want logs in the first place. I mean, yeah, that's also a good point. We will probably want to make this step. The thing is, that's not the optimizer technically. The optimizer will be a phase that runs on the IR to try to remove dead code and things like this. This is purely a cleanup phase on the bytecode. So, but it is part of the optimizations. I suppose, yes, we could consider having this be a separate part. It's a good point, actually. Maybe we will want to disable that at some point. And maybe, therefore, this becomes a new phase. We have optimizations that take an IR, returns the IR, and we have the minimization phase then that takes an instruction buffer and returns a minimized version of it for size. If that becomes a dedicated phase, it solves some issues. I am actually tempted to do that. I think you have a point there. This should be an optional phase. So let's move away this simplify to be instead a minimization phase. I will just quickly go delete this simplify file that no longer needs to exist. So now this is minimization. Okay, so we found push depth 1, push steps 1, roll, push depth 2, push steps 2, roll, and some kind of other thing. And the depths were the same. We return a new sequence, which is made of push int depth 1, push int steps 1 plus step 2, roll, followed by the rest. And I probably want to make a small helper function, which is going to be some kind of like on prefix, which is going to be given an int and given no. No, actually, we can do that. Okay. Given an int and given a function from sequence of instruction unresolved, which is an instruction buffer. So given a sequence of instruction buffer to maybe... So the same thing as a rule, but I want to keep it separate. And takes an instruction buffer, returns maybe an instruction buffer, and this will be on prefix of size n. Apply the function f, and this will be case f of, well, let segment 1, segment 2 equals sequence split at n of s in case f of segment 1 of nothing. We didn't find a rule to apply, we return nothing, in which case I can in fact just do that as an f map of segment 2 on f segment 1. There we go, and this becomes on prefix 6 case empty return nothing. This thing where depth 1 equals depth 2 returns that, and I don't need to include the rest in that anymore. Otherwise, Anything else? Nothing. Which means I can probably do that. However, this will only apply the rule on the first. So now here I might want to instead do a case f segment 1 of, if we got a new segment, we return just new segment plus segment 2. Otherwise, we need to iterate on the sequence of instructions. And that will be done by in the case of nothing, then the result will be we try recursively on prefix of size n the same function f, and we do that on sequence drop 1 of s, and we do an f map on that, which is to do a sequence drop take 1 of s. There we go. Okay. I'm gonna rename this because it's a horrible name. This is traversing a sequence to try to match this is just an apply rule, I guess. So now we apply a rule of size 6, and the only thing we do is if we match this particular pattern, and the reason why I'm doing this is because I need to be able to do equalities. This is not matching actual constants. Then we can replace with this. Perfect. And now we should be able to do remove roles. And that is if I have a role, a push depth, push steps role, where steps equals 0 or steps equals depth, return nothing, because that is an operation that does nothing anymore. We probably also want to remove that's a rule 3, I guess, here. There is another one I want to write. However, this is one for which this apply rule thing doesn't work, annoyingly. So I'm gonna need to rewrite it more. What I want to detect is basically I have a series of pushes followed by a roll. Because if I have a series of pushes followed by a roll, and the roll is of a size that's less or equal to the list of the depth of the roll, I can remove the roll to just reorder the pushes in the right order. Yeah, it means this split doesn't work anymore. So it means instead, that I'm gonna need to split this into two functions. I'm gonna have apply rule that takes such a function. And this is going to be apply rule will be case fs of just a new sequence. That's just, oh, unless I optimize it for tail calls, I think I may want to do that. So this is gonna go sec empty of s, where go left hand side of s is case fs of, and this is gonna be the rule, and n no longer exists. So do we apply the rule on the segment S, and did it give us something? Then we return the left-hand side and the sequence. Otherwise, it gives us nothing. We go recursively with the left-hand side having one more element, which I suppose will be, I can do a case view L of S of, where's sequence? On list, this would be a lot easier, but at the same time, lists are worse. So empty L is what I want. Okay. So I have an empty thing. That is weird that it happened in the first place, but that means we return nothing. And we have otherwise an element X at the beginning of the rest of the sequence. And that means we go recursively. The left-hand side gets the X element added at the end. And we go recursively on the rest. There we go. And now I can make segmented is something that takes given some int and a underlying function and a rule makes that a new rule, I guess. And this doesn't do the recursion anymore. This is purely split at n of a given sequence. If the rule applies on the segment 1, then we return new segment and segment 2. Otherwise, nothing, because now we have separated into the recursion here, which means we are back to this is fmap segment 2 of rule segment 1. Okay, so now merge roles is apply rule of segmented 6 of this function that matches this pattern and replaces it, or otherwise do nothing. Remove roles is apply rule of a segmented 3 that looks for this particular pattern. If it finds it, I need to so here it is there, because the type of rule is a function from instruction buffer, which is a sequence to maybe a thing. So this, in fact, you could see it as returning a rule, so returning a function that takes the sequence and does the rest of the thing. But as far with curryfication, it is the same thing as having the sequence on this side of the equal sign. Because curryfication, a function like in Haskell, any function of more than one argument is a function of one argument that returns a function. So this is in fact a function that returns a function that takes the rule, that returns a function that takes the sequence, that does. But it is easier to write it that way. Okay, so now we have something a bit better. And now I can do reorganize stack, which will gonna be an apply rule, but not a segmented, because it's not gonna be on a particular size of instruction. This is gonna be a more complicated one. This is gonna be something where, given a sequence S, we're gonna try to match so I want to do a partition, I think, in this case. No, not partition. A span. Okay. So here I want to do a span L of is push of the sequence. So, and this will be something else. And what is push? That is a very simple thing where if we find a push int, that's true. If we find a push address, that's also true. Everything else is false. So this is purely, did we find a push instruction that puts a new value on the stack? Now, we try to do a span of is push, and we are interested in the case where we find a bunch of pushes and we find on the right hand side a roll followed by more instructions. And specifically, we are interested in the case where oh, this is annoying. Oh, this is annoying. I am interested in the case where a view R gives me the steps before a view R gives me the left-hand side and the depth. Okay, this is kind of horrible, but basically I'm using the view pattern thing to say, okay, we've done a span that gives me a pair of the longest sequence that matches the particular predicate is push, followed by the rest of the sequence. And I'm applying this function on the right-hand side and then matching this pattern. So this whole thing will match when the result of the span on the right-hand side, when I do a view on it, I have a roll followed by the rest of the sequence. On the left-hand side, which is the longest span that contains is push, I am decomposing it using recursive calls to view R to obtain the left-hand side, followed by the depth, followed by the steps. And now what I need to know is I am only interested in this particular case when depth is less or equal to the length or size. I'm assuming length. The length of the left-hand side. So we are doing a bunch of pushes, which are known values at compile time, followed by a roll for depth, which is less or equal to that length. When that happens, we can simplify. Otherwise, we return nothing. Okay, that is tricky. But now what we can do in this case is we know we can remove the roll altogether by reorganizing the order of this left-hand side to match what the roll would have done and just optimize it away. Which means this is going to be ultimately something followed by the rest of the sequence there, because we are doing the split here manually with a span. And this is going to be, I guess I can do a roll depth steps of the left-hand side and put that in another function here for convenience. And roll depth steps of a sequence will be, I will need to do a split on the right-hand side. There's no right take. That's extremely annoying. I remember that. So that means I need to the true left-hand side that I don't care about and the part that is rolled will be a split at length of s minus depth of s. This is the wrong syntax. This is a let. Followed by what we are actually rolling. So I need to be careful. The last things that are in my left-hand side here on the rolled are the top of the stack. So I need to split at steps. . And I need to split again at the end. So this is segment 1, segment 2 will be the result. This is going to need some testing of splitting at length, at depth minus steps, I believe. Of what is being rolled. And the overall result of all of that nonsense is going to be the left-hand side, segment 2, segment 1. We are simulating the roll at compile time, and we can remove the roll altogether. Okay. That's another optimization. Now, there was another one I had in mind. I had an easier one in mind. Another rule I wanted to do was remove redundant jumps. And that is a very simple rule, which is apply rule segmented to when I have a push, 3 actually. I have a push int of a address followed by a return followed by an entrance with an address. If I look at my bytecode again, push address, that's correct, and entrance address, push address, in the case they are both address. Okay, so that's correct. And let me just check in my generation code. Then when I have, for instance, when I generate a jump at the end of a thing, the generate jump here, that's part of the monad. It is push address return. Perfect. Okay. So what I'm saying here is a push address return to go to the same address is useless. So when that happens, we can replace that with just entrance address 2. I am also tempted, as a result, to do a thing where we remove if a address is always jumped to directly like this, we might end up in a situation where an entrance ends up being unused. So we can as well just do remove unused entrance. And that is going to be something that doesn't use the apply rule thing. And this is going to be okay. How do we do this? I'm gonna do a fold on this thing. I'm assuming fold L is it is as part of foldable, okay. I'm gonna do a fold of identify of get addresses on the sequence, which is what this thing takes as an argument. but then I need to name it anyway. So take a sequence, which is the buffer, and we are starting with 2 empty hash set. Collect. So this is going to be jumps and entrances. And we are in fact going to operate on sequence drop 1 of S, because the first entrance needs to always be kept, I guess. Next, okay, and on that we will do something. What we want to do here is collect the addresses. And that is a very simple thing where we have jumps and entrances. And we find an instruction. And if that is a push address, then we add that address to the jumps. If it is an entrance, we add it to the set. Yeah, that's a very good point. We can try. In theory, most of those should already be handled by the simplification phase we have on. Like, we already have, in theory, a simplification phase that happens on the AST. And I do, in fact, not want to do that for a reason. I'll get into it. I'm just finish this, and I'll get back to it. Entrances and any other instructions, we return the accumulator unmodified. So this is returning the jumps modified and the entrances unchanged. The jumps modified and the entrances changed. The accumulator unchanged. Okay. The reason why I don't want to do simplification of push into add or multiply at compile time is twofold. First, we already have a simplification phase that tries on the AST to apply a bunch of rules, which I expressed here purely in terms of like matching on the AST, which is a lot easier than matching on sequence of things, where we find the addition of left-hand side plus 0 is just the left-hand side, addition of 0 plus the right-hand side is just the right-hand side. So a bunch of those things get computed at compile time. During the analysis, we also have constant unfolding that will do that for us. So in theory, all constants will already be unfolded by the point we reach code generation. Furthermore, there is a thing that we're going to decompose into a series of pushes like this with add and multiply that I don't want to recombine. Let me show you what I mean. This would be in... This is not in generation, I think. Is it in assembly that we do that? Yes, here I have a thing. No, it's not here. Append instruction, expand instruction. There we go. Every push I find, I translate into a combination of push, multiply, and add. The reason for this is a push is proportional to the size of the segment. So for instance, here, if this is a push, which I think it is, this is a block of 8 pixels that goes into a block of another color. And the push is a push of 8 because there are 8 pixels in this thing. We support int64s, which means if I wanted to push an int64, I would need a block of that number of pixels, so 1,000,000 pixels or something like this. So instead of doing that, every time I want to push a number that's bigger than I think 16, I decompose it into base 16 by doing a push the value multiplied by 16 plus the value multiplied by 16 and so on to have to basically enter it as a sequence of blocks of units of base 16 rather than having a million pixels of a thing. So in fact, I decompose pushes into push, add, multiply rather than grouping them this way. So here, I don't think I want to add a minimization rule for that. So here, at the end of this, I will have collected all of the address that have been added before a jump, and I will have collected all of the entrances that have appeared as a target of a jump minus the start of the function because I drop one here. What I want to find is all of the entrances that do not appear in a jump. And that would be unused. And unused will be, I don't know if hash set has a convenient operator for this. There it is. Does it have a difference operator? It has difference. Perfect. Return elements of the first set not existing in the second. So I will want the difference between my entrances and my jumps. This will give me the entrances that are not, that we don't jump to from like local addresses that we never reference within the function. Those are unused. But that doesn't mean, in theory, we've already done dead code elimination, so it means they've been removed, the jumps have been removed by another minimization phase, and in which case that means if unused is null, then we return nothing. Otherwise, we are gonna do a concat map, essentially, on our sequence. Is there a concat map here? There should be one from the just a fold, basically. Let's look at foldable again. It's a fold map, basically, I think. Yeah, it's just... else fold map remove unused. Of S. Fold map is going to be something that to an element gives me a sequence. And fold map remove entrance with the list of the unused ones is gonna be a case of I have an entrance with an address, and that address is a member of the unused ones. We return an empty sequence. Any kind of other instruction needs to be kept, and we return a sequence, which is just that instruction. That's a concat map in a sense. So we replace all of those by empty sequence. We replace all of those by sequence of one element. And I guess maybe if there's a filter, this would be even better, rather than doing a concat map like this. I'm assuming there will be a filter on sequence. If I can type, there is filter. Returns a... Okay. So this is in fact just a filter. That's easier. Oh, I can even go one step further. Does hash set have not member? No, some sets do have that, but it doesn't. I want to keep the things. So given an instruction, oh no, I probably want to do it with a function because I need to decompose. Okay. So remove entrance unused. And remove entrance tell me, hello, how are you? Must be removed. That's a predicate. Must be removed given a list of unused instructions. If that's an entrance with an address that is part of the unused set, then the answer is true. This must be removed. This is false. It must be removed. Ah, so this is must be kept. Or I guess I can do a not must be removed and must be removed true. Otherwise, any other instruction, the answer is false. It must not be removed. Okay. So now we have our list of minimization rules that merge adjacent roles, remove roles that do nothing, reorganizes the stack whenever we have a series of pushes followed by a role that can be simplified, remove redundant jumps, and removed unused entrances. Now, we're gonna need to test the hell out of this. So first, let's check that it compiles. We've moved this file since we've created it. So first we need to, there we go. Roll here. Why are you unhappy? Because it is not indented properly. Yeah, I will absolutely do that. Because I think there are some cases, typically, there are in this very program, there are places where we do this kind of stuff. I think here, this is, let me actually open a traced version. Here in our main, we do a push 1, push 10, push 2, push 1 roll, which is basically push those two numbers and then swap them. So we should be able to replace this as push 10, push 1, and remove the 2, 1 roll here. So that should make a difference. And there's another one that I think that we could find. I think we had a roll that was useless somewhere else. No, push 1, push 2, push 1 roll that cannot be removed. No, I don't see any other example here, but this one is definitely a case where our reorganized stack thing will show a difference. What I want to do as well is something that gives me, for an even function, just prints the one image so I can see an image of a function in isolation. I don't have that yet. This will be very useful for debugging purposes. Okay. I'll go back to this. Oh, do I have IR in scope here? I think I can just remove the IR import because this is operating purely on bytecode. There's no fold L. Oh, because it's just using the foldable one. Is the one in list the foldable one? Okay, so perfect. I will want to import a bunch of things from sequence to have them in scope. I will want this operator, I believe. And I will want view L and all of its constructors, view R and all of its constructors, view L, view R. I mean, at this point, do I want to just import sequence altogether? Maybe I do. I just want to have all of sequence. Ah, I don't need lens in this module. I can just remove that, I think. Okay, so here I probably want to be specific. That's the length of the sequence. Depth is not something, yeah. Okay. Instructions. Ooh, fun. Is it a kind of like demo scene kind of thing where you inject like a 4K kind of program kind of thing? Like a cracked row of the nice. I used to be part of a demo scene group more than a decade ago. It was fun. I didn't do a lot of the work there. Most of my friends were doing the most of the work, but I did help them at any bit for a few things. It was a lot of fun. One of our 64K got nominated for a prize. We didn't win, but still, that it's neat. I renamed it from S to sequence. Okay. So now so this is a rule. So it must be a function that takes a sequence and returns something. So this must be in fact a dot here, not a dollar. And most importantly of all, in our list of rules that are applied, we need to add remove roles and reorganize stack and remove redundant jumps and remove unused entrances plural actually. Okay. Good. Now segmented is a function that given an int and a rule function gives me a new rule. And apply rule is a function that given a apply on all prefixes is a transformation, is a combinator from rule to rule. So apply on all prefixes. Apply on all prefixes. Okay. Okay. So we agree that this is something that takes a rule as an argument. Oh, but no. Okay, so it must take. So I'm wrong. I am wrong. this is indeed something that puts a dollar here, because this gives me a rule and apply on all prefixes, transform a rule into a rule. Okay. Okay, so this works so far. Instruction unresolved. Let's see. Ah, yes, of course. That would be, I have a bunch of pushes that I decompose with those view R kind of thing, but here depth and steps are not just variables, they are push int. This is what I want to match here, in the same way that I'm matching roll here. Without the typo. Okay. Aha. Entrance address unresolved. Oh, this should be a push address here. Oh, they push int. Because this becomes a push int after linking, which hasn't happened here yet. This is indeed minimize and not simplify. And there we go. Now we are at the point where we have warnings and not errors. That's good. Yes. I might just replace. Oops. And I know I've made a mistake on an S dot somewhere. Yes, here. There we go. This is the right-hand side. There we go. Okay. Now, let's try this in GHCI. I'm just gonna fully reload it. So let's set overloaded lists so I can just type a list as a sequence, or rather the other way around. And now I want to test minimize. So first is a very simple test. I push int 5 and I push int 3 and I roll. Then I push int 5 and I push int 1 and I roll. This should apply the first, the merge roll, and I do indeed get a push int 5, push int 4 roll. I have removed the unnecessary roll. That's good. Now, if I do this as a push int 2, both rules have applied. So first we've applied the rule of the merging the rules, then we've applied the rule of nullifying them. And just to confirm the thing we were saying earlier, if I change the order of the rules here, not sure why it's recompiling all of this. What? Oh, because... Oh, that's annoying. Okay. So when I set the overloaded lists flag in GHCI, it didn't set it just for the current thing. He set it for all. It set it for all of it. That is extremely annoying. So instead, I'm gonna do import data sequence um, from list f equals from list data sequence list, which means now I'm just gonna do minimize of f of that. Okay, and so that still works after splitting them, confirming that the rules do reapply properly if something happens. Now, I would like to test something more interesting, which is I have push int 1, push int 2, push int 3, push int 4, push int 5, followed by push int 3, push int 1 roll. The roll has been removed because the rule about reorganizing the stack has applied properly. The question is, has it done the computation correctly? One sec. I'm going to debug this one and then I'll try the one you suggest. So here, 1, 2 are not in the part that is being impacted, so they remain the same. And then this is a push in 3, but 1. So 3, 4, 5 are being... So it should become 5, 3, 4. That works. Okay, so the segmentation, the reordering of the stack to avoid unnecessary rolls seems to be working. So you're suggesting push int 2, push int 1, roll, push int 2, push int 1, roll. This, let's think about it ahead of time. This should first merge the two rolls, so we get a push 2, 2 roll. Then it should realize that roll is useless and should therefore only give us one remaining roll at the end. Yep, okay. So the merge here happened, then the simplify happened. Okay. Now, let's try to have a look at... Here, I'm actually going to run an actual test instead. Let's go to main. Our ugly main that I started this evening trying to clean. And I... okay, I can do that. Ah, so you want to see if they apply recursively properly. I see, I see. So this would be... I seem to not have it in my history. That's fine. Let's redo it. So that would be, we do a push. In fact, I'm kind of tempted to... push to 1 is going to be a segment of push int to push int 1. So we want to do a minimize of f of... So push to 1. roll. Push to 1. Followed by push to 1 roll, push to 1 roll. So we have the push to 1 roll, push to 1 roll. We have a push to 1 roll, push to 1 before. We just need a second roll at the end. I think that's the use case you wanted. We get an empty list. So that works. Okay, now to test the rest of the optimizations, I think what I will want to do is here, I have this all functions at a hash map, traverse print all function. I think instead I'm gonna do a traverse with key, and do I have, yeah, print instructions. So bytecode. And then bytecode minimized. After doing minimized functions equals a simple minimize on all of the functions. And here we're gonna apply this on the minimized, oops. Minimized functions, and here minimized functions. Okay, so I just need now to do a print instructions, which is gonna be a instruction buffer here, which might not be in scope. I might need to add it. And this is gonna be a very trivial thing of putting a that plus show of the instructions. I think this is gonna be good enough. Okay. Instruction buffer and in scope, I need to add, that is bytecode here. Minimize not in scope, I need to import one new stage, which is the minimization stage that we've just created. Okay. Now let's try this on here, which is okay. I think I want to try to copy this into Emacs on a scratch buffer. Okay. I think I'm just gonna rename up I'm just gonna keep the label for the entrance. There we go. Push address, likewise, I'm just gonna keep the label. Which means I'm just gonna up, there we go. So that's the unmodified, unsimplified version. That's the minimized version. Oh, I'm printing more things at the end there that I don't remember. Oops. Print instructions, print instructions. What are those? I'm not sure what this is. I thought I had removed. Oh, maybe I have some more prints at the end there. Weird. Or maybe it's part of the. I don't know. Oh, diagnostics. Maybe I have warnings. No. I have no idea where those come from. It's not that. Instructions. Maybe somewhere in there I do actually do some IO manipulation or something. Weird. Weird, weird. Anyway. Let's copy this here. Back to Scratch. Do the same replacement that we just did. Okay. So main now, we had the entrance. Okay. Main. Okay. Followed by push. I'm going to remove this entrance again for readability. So before minimization, we were doing push int 5, push address, push to push into push int 1 roll. Now we just do push address, push int 5, push address return. So we've removed the push into push into 1 roll because we've detected that the two pushes could be swapped. Okay, so that's good. And that's about it, I think, for this, because after that we have, yeah, the push address, the pop return, and we have return the entrance pop return the same way. For this big function, what do we have? Here we had push in 1 to 1 roll, hasn't changed. Duplicate push in 3 to roll, duplicate push 3 to roll, that's the same. I think nothing here has changed much. Ah, but do we have entrance? There was a return. It's still there. Okay. It does seem like there are fewer instructions. Let me do that. And take that, open a new Emacs on the side. Or in fact, no, just do that and scroll back here and do the same kind of replacement. Yeah, there's definitely less stuff. So what has changed? Oh, I'm looking at the wrong function. That explains why I am looking at the wrong function. There we go. Now that's the correct function. Okay, so push one, push to one, roll, duplicate, that looks the same. Roll greater, push address, that's the same. I've made some changes. Up there we go. Push to one, roll branch pop. Nothing has changed. I could not remove any jump. There was no jump to remove. Maybe here I see push address, push address. I see no change there. Yep, nope, I don't see any change there. Nope, sadly, there was no jump to remove anything like this. So let's try manually then. Go back to GHCI, and is it big enough? I've zoomed out slightly. Let's try again now the minimization function, but like not on the actual program. Let's try by hand. Oh, actually, let me look at something. Okay, thank you for checking. So this is the code as it was before minimization. Now, if we look at this one, there should not be a lot of changes, but the one change is the main function here has fewer blocks compared to what it had here, because here it was doing a bunch of pushes followed by a roll, and that has been removed for fewer pushes here. I think that's the only change that we have observed. Now, we want to try, what if I have a push address? It's going to need to be actually an address. What is an address? Again, it is a name and a label. Okay, let's introduce the name. It's gonna be a name that's gonna be just, if I do foo and bar, it's not gonna work, right? So let's do an example name, which is gonna be a name where we have a base name interactive foo, and the parameters are empty list. Not, no instance for is string module name. I think a module name is a non-empty list of identifier. Yeah, okay. So there we go. So now we have a name, which means I can try a minimize f of, we do a push int, we do a push address, which is n and a label 1, 1, let's say, which is our return address, followed by push int 5, which is our argument, followed by a push address n label 2, 2, followed by a return, followed by the entrance for the label 2, 2, followed by whatever, multiply return. Annoyingly, I have more than one thing called return in scope. So let's be explicit, it's this one. Okay. So if I do that, we still have the push address. The push int 5. Oh, but we remove the entrance. We remove the entrance, of course. Because we did apply first the... We applied the remove the redundant jump because we have a push address return entrance. So that's just, there's no point in keeping this. So we remove that return, which means we remove the push address into return, we just directly follow through the entrance. And then we realized, well, we now have an entrance that's not referenced by any jump. We might as well remove it, which means if I remove this and recompile, define but not use, that's fine. I need to redefine the name. I need to redefine f. Now, in this case, I've removed the rule to remove unused entrances. We still have the push address. We still have the push int, and we still have the fall through to the entrance. That then contains a multiply and a return as expected. But if we put this back, then this optimizations with the sets does remove the jump and then realize that the address is unused and removes it as well. Okay, so that's a new phase, I suppose, because we probably want to make this optional. Well, we want to make it enabled by default, I think, but we probably want to make it to have an option to disable it when we want to try to debug it in isolation. And we will probably want to see if there are more rules we can apply on the bytecode. Those are the trivial ones, but there might be a few more things that we might be able to detect. Let's have a quick look actually at the bytecode and see if there's anything obvious. I am not going to do any arithmetic simplification here because, again, there's going to be 2 phases of optimizations before that that will take care of that. There's probably ways to simplify a branch in the same way. Like maybe I could detect, since branch is often preceded by a not, I could detect like a not branch and just make that a not branch and flip the jumps, I guess. There's probably some things like this. I think simplifying the roles was the biggest one. It's gonna make a difference. Okay. Well, that's enough already. That's already gonna make a bit of a difference. And it's already oh, it's a bit later than I thought. Okay, I might stop here this evening. We started slow with my work on the build graph. That's not very good. I'm not super happy with it. But we did end up making some progress on the minimization, which is the thing that I wanted to do anyway. I think for next time, either tomorrow or Thursday, probably Thursday, I'll try to prepare a tiny bit more ahead of time what I want a build plan to look like so that I know how to approach the build graph problem rather than just improvise it on stream. It's something, as much as I have this strong rule of no code is written outside of the stream, preparing the streams ahead of time, like thinking how do I want to approach this problem, is something I do quite a lot. This time around, was like, here's the list of things I want to tackle, but I did not spend any time thinking about how I would tackle them. And you can tell by the fact that I was hesitating a lot more on the stream. So yeah, I think for next time I'll prepare a tiny bit more in terms of like how do I want to tackle those problems. And yeah, I think it's time to replace I think it's about time to replace this nonsense with something that does a proper build plan and executes a build plan. Maybe next time I'll also think about the thing we mentioned of having a some kind of logging monad kind of thing. I think if I do that, I will probably do the same thing I've done here, where I define a type class trait thing. It was like, oh, my monad M has the capability to do those things. That way, for main, I use IO, and for tests, I use something that just returns something hard coded without side effects. I might do something similar for like a logging monad. I'll look at what libraries exist actually. Maybe I will want to reuse something that's standard, but otherwise I'll probably do some kind of monad logging kind of thing where I'll have like a like output log thing which in tests will not print to the standard output and in main will delegate to whatever the monad is to decide where we put the thing. Yeah, I think I will want to do some kind of logging on the minimization. I think it's useful to have in the logs. Probably in the verbose logs. We don't need that for basic compilation. But yeah. Which means actually if we do that, it's gonna be fun because now a rule will be something of that shape. And now all of our combinators are monadic, and that's gonna be fun. Anyway, I think I'm gonna stop for this evening. I have to be up early tomorrow. I am going to commit. Let's see. What have I changed that's significant here? Okay, so first, let me commit changes to the parsing monad. Yep, and to parsing here, and to diagnosis. That is a significant change where now parse errors are properly reported rather than those functions returning a either a parser, which is a string, or the thing. They return something in monad diagnosis. So that's a big progress. And I need, if I commit that on its own, to include one change Here, I need to remove this. The rest can stay. Okay. What has changed in the analysis? That's different. Okay, I'm gonna commit that separately. So that's first parsing properly report errors in monad diagnosis. Then we have analysis and interface. Analysis include imports in interface. Then what do we have here? I'm going to add the minimization first. So commit this one and minimization there. What has changed in bytecode? Ooh, object. No, okay, that's not required in the previous commit. I didn't mess up. So that's we've added minimization, the new minimization phase, and I can commit this and this. Oh, I probably have like some debug trace in the assembly. I think that's what it was. I'm probably gonna try to remove that. So this is add new minimization phase. Then what we have here is add pipeline, I suppose. Add draft of build graph. It compiles, but I don't think it's correct yet. Now, the last thing I want to change, want to check is, do I have a trace anywhere? I do have a debugger trace in assembly. That's why I had those extra lines that I did not recognize. I left a trace there from last time. Do trace show m. There we go. Trace show m. I am going to remove that. Check that it compiles still. It does. And now I don't have weird lines. I have the definitions, the functions. Oh, yes. I don't have any generic function in this. Oh, that's a test I wanted to run actually. I have the symbols Fibo and main. This is a test I wanted to run. Let's see if this works. I wanted to try to make this a generic function over the type of the argument. Given that I'm doing numeric operations, it cannot be anything but int and will be instantiated with int. But this allows me to check that the instantiation of symbols works correctly. Okay, that seems to have compiled. And now the difference is in the definitions we have main and Fibo, which is a function that has a parameter t. In the functions, we have the generic function Fibonacci because another module could import it and create a new instantiation. And in the symbols of the main module, we now have the instantiated version of the function with the type built-in int as a type argument, where as a result, the arguments should be of type int, identifier x of type int type. Wait, nope, that's something else. Type info int type, there we go. And the IR also has, okay, the generated IR for this instantiated generic function. And then the same bytecode, and that's the same. Okay, so that still confirms that our analysis and instantiation of generic functions still works, which is nice. What else? What else? I think that was about it. Yes, I've just removed a mistake in debug.trace. I'm gonna comment that. Push that to GitHub. And that's gonna be all for this evening. I probably won't be able to do an extra stream tomorrow evening. My usual are Tuesday, Thursdays, and I've been trying to do Wednesdays when I can. I probably won't be able to do tomorrow evening, which means I'll see you all on Thursday. Thank you everyone for tuning in, and I'll see you then.